We now want to be able to simplify these rational expressions when we have multiple pieces in the denominator. So looking at these two rational expressions that we want to add them together. We have 3 halves plus 5x over 2 times the quantity of x plus 1. Now right now in the denominator we already have one of those factors in common. We have the 2 that's in common already. But what we don't have in common is the factor of x plus 1. So in order to add these together, we need to make sure that we have both of those factors the same. So we need to multiply this first fraction by that missing factor of x plus 1 in both the numerator and the denominator. When we do that, I'm going to go ahead and distribute the 3 into the numerator. So I get 3x plus 3 over the 2 times the x plus 1. And then add that to what we already had, the 5x and the 2 times the x plus 1. And I don't need to do anything to that second fraction because it already had both the factors of 2 and x plus 1. But at this point, we can look for any common terms to simplify up in the numerator. And the denominator, when I combine this, is going to remain the same. That 2 and the x plus 1 don't change. But when I'm looking at the numerator, I've got 3 x's from the first fraction, I have 5 x's from the second fraction, and the operation in between tells us that we are adding those. So 3 x's plus 5 x's would be a total of 8x. But then I've got this positive 3, and then I've got nothing from the second fraction to combine it with. So I'm just going to say plus 3, and that would be our combined expression. So we recognize from the very beginning that the factor of 2 was already in common. We were just missing the factor of x plus 1 in the first fraction. So we multiplied by that extra factor. Once we had done that, we combined our like terms and then simplified what we could. Now using that idea down on another problem, we can look at these two rational expressions and see that we don't have anything in common in the denominator. Because right now, if I look at this x plus 2 is its own factor, and the x minus 5 is its own factor. So even though they have an x in common, that plus 2 or that minus 5 is part of that. And so I need to include that as part of the entire factor. So really, we don't have anything in common between these two denominators. And so both of these fractions need something that they don't have. So this first fraction, I need to multiply by an x minus 5. And the second fraction needs to be multiplied by the x plus 2. And once I've done that, I now have both an x plus 2 and an x minus 5 in both denominators. So if I go ahead and actually multiply out the numerators, I have in the first fraction a 2x squared minus a 10x, and then over the denominator of x minus 5 and x plus 2, because that doesn't change. But then I still need to subtract that by the second fraction. Denominator is x minus 5 and x plus 2. And then the numerator, if I distribute that 6x in, is going to be a 6x squared plus a 12x. So now we're to the point where we have the same denominator. We can go ahead and try to combine our numerators. So I've got a 2x squared from the first fraction and a 6x squared from the second fraction, and the operation between them tells us we're going to be subtracting. So the 2x squared minus 6x squared is going to end up giving us a negative 4x squared. Then if I look at just the x terms, I've got a negative 10x, a positive 12x, and again, I'm subtracting those two together. So a negative 10 minus 12 more would put us at negative 22x. And then the denominator that we had in common already was the x minus 5. and the x plus 2. That would be our simplified expression. So we recognized from the very beginning that nothing was in common between the two denominators, the x plus 2 and the x minus 5. So we multiplied the opposite fraction by those missing pieces. Once we had done that multiplication, we looked at common terms between the x squareds and the x's and subtracted them to get our final expression.